Hello, this is Ms. DB, and we're going to do a special section on applying special right triangles. The warm-up is a review that we should do. The first one says to find the missing value of x. If it's the hypotenuse, like in number 1, you'll write 5 squared plus 10 squared equals x squared. And in number 2, it actually is the same thing. So let's see what we get here. The answer is already showing, but that's all right. So you'd take 5 squared plus 10 squared will be equal to x squared. Then you square 5 and get 25. You square 10 and get 100. Now you get 125, but it doesn't say to leave it as the square root of 125. It says to leave it in simplest radical form. So let's see. 25 times 5 is equal to 125. So if I write it this way, the square root of 25 is 5, and when I leave the square root of 5 is the square root of 5. So 5, 10, and 5 square root of 5 would be the missing side. In this triangle over here, I'd go 2 squared plus 3 squared equals x squared, because again, we're looking for the hypotenuse, which is the variable. So 4 plus 9, and that's 13 equals x squared. Now that one, to simplify that, you really can't. There's no perfect squares within 13, so you just leave it as the square root of 13 equals x. Now, in number 3, we have the square root in the denominator. That's not allowed. So we do something called rationalizing the denominator, which would give us 12 times the square root of 3 over square root of 3 times square root of 3 is 3. Now, we're still not done because you can simplify the 12 and the 3. This 3 can go into 12 4 times. Now, nothing changes with inside the square root. That's like a separate thing. So we would just get 4 square root of 3 for this. In number 4, we have to rewrite the square root of 20 as the square root of 4 times the square root of 5. But the square root of 4 is 2. So we'd have 2 square root of 5 divided by 2. And again, these will cancel. Nothing happens inside the square root, so this will just simplify to the square root of 5. All right, we are going to learn some special things that happen if you have a 45-45-90 triangle or a 30-60-90 triangle. So both of these will be right triangles, and some special things will happen. If you have a square, every angle is 90 degrees and every side is the same length, right? If we divide that right here, this is the same as this. This 90-degree angle gets divided into a 45 and a 45. So we end up with a 45-45 triangle. It's a special right triangle, and we can find a special relationship on the sides of this. Every 45-45-90 triangle will be similar to each other, and they will all have this relationship. Whatever the side length is, if it's 8 or 3 or 9, the other side will have the same length. These two sides will be congruent every time it's a 45-45-90 triangle. The hypotenuse of that triangle will be equal to whatever that side length is times the square root of 2. So if L is 8, this would also be 8, and this would be 8 square root of 2. If this was 5, this would be 5, and this would be 5 square root of 2. So as long as we know one of the legs, we can find every other side. Also, if you know the hypotenuse, you could divide it by the square root of 2 in order to find the legs. All right, so here we have a 45-45-90 triangle. We know that because this is marked as a right triangle. These will both be 45, and we need to find x. Well, this is 8. This will also be 8. I could use the Pythagorean theorem, but it's even easier to say, well, I'm going to use this theorem. Every leg, or one leg times the square root of 2 is equal to the hypotenuse. So all we have to really do is say that the answer is 8 times the square root of 2. So it's a shortcut when you know you have this special kind of triangle. Now in this one, we're giving the hypotenuse instead of the leg. But I know that the leg times the square root of 2 would equal 5. So what we need to solve this with then, x times the square root of 2 equals 5, I need to divide both sides by the square root of 2 to find my answer. Now in the warm-up today, we did a problem where you have a division by the square root of 2. And I said you have to rationalize the denominator, which means to multiply top and bottom by the square root of 2. And when you multiply this by the square root of 2 and this by the square root of 2, you end up with 5 square root of 2 divided by square root of 2 times square root of 2 is just 2. That's your answer. That's in simplest form. That's how you want your answer. Okay, in this one, we know that the leg is 10 square root of 2, and we want to find the hypotenuse. So we have to take 10 square root of 2 times the square root of 2. Now don't think that because it already has square root of 2 with it, you don't have to multiply it by the square root of 2. You still do, just like the theorem says. But what is the square root of 2 times the square root of 2? The square root of 2 times the square root of 2 is 2. So this part right here is equal to 2, and 10 times 2 is 20. So the hypotenuse would be 20. Okay, here's one more example. In this one, we know the hypotenuse is 16. So this is one where we're going to find the leg. So we'll be taking 16 divided by the square root of 2. You can't leave your answer like that. So what you do is you rationalize the denominator by multiplying top and bottom by the square root of 2. Now when you do that, you get the square root of 2, square root of 2. You get, they're skipping the steps, but you'd get 16 times the square root of 2 divided by 2. But we have to simplify that because 16 divided by 2 is 8. That's where they got the 8 from. The square root of 2, this part stays the same, and they just rewrote it right here. So 8 square root of 2 is the answer. Okay, this is just an application. It's a square. Okay, draw a picture. Got a square. Every angle is a right angle. And the diagonal is 36. If you take a square and draw the diagonal, you created a 45-45 triangle. Right triangle. She wants the diagonal of the tablecloth to be an extra 10 inches, so it'll hang over the edges. So instead of 36, we're going to change this to 46. Now what we are looking for is what is x. So we're going to take 46, divide by the square root of 2, and you'll be able to find one side length. And that means rationalize the denominator. However, if you're rounding to the nearest inch, you can type this into your calculator. You can go 46 on your calculator and then divide by square root of 2. And it's close to 33. Okay, there's another type of triangle. There is a 30, 60, 90 triangle that has a special relationship. In a 30, 60, 90 triangle, we have one angle is 30, one angle is 60, and then it's a right triangle. So if you know the short leg, S for short leg, I guess, if you multiply the short leg by the square root of 3, you'll get the long leg. If you multiply the short leg by 2, you'll get the hypotenuse. So this is our short leg. Hypotenuse. All right, so let's look at one of these in action here. The relationship is the short leg times the square root of 3 equals the long leg. That's one of our relationships. So the short leg is x times the square root of 3 equals y. That doesn't help me out. I also know that the short leg times 2 is equal to the hypotenuse. That might help us out because I don't know the short leg, that's x, but I do know that the hypotenuse is 22. So that's going to allow me to find the short leg. Find the short leg first. So the short leg is equal to 11. Now that I know the short leg of 11, I can multiply that by the square root of 3 in order to get the long leg. And now I found everything I need to find. So I've got 11 square root of 3 for the long leg, and I've got that the hypotenuse is 11. Okay, let's look at another example. In this one, we know the short leg is x. That doesn't help us much. We know the long leg is 15, and the hypotenuse we don't know at all. All right, so the long leg is equal to the short leg times the square root of 3. The short leg is x. The long leg is 15. So we have 15 equals x times the square root of 3. Now you have to find x. So we have 15 equals x times the square root of 3, but we want to find x. So the best thing to do would be to divide both sides by the square root of 3. And when we do that, we'll get 15 divided by the square root of 3, and we have to rationalize that by taking 15 times the square root of 3 divided by the square root of 3. But like that. So we'd have 15 square root of 3, that's not a 6, divided by 3. But 15 divided by 3 is 5. So this simplifies to 5 square root of 3. Now what was this? This was the long leg. We still have to find the hypotenuse. Oh no, this is the short leg, sorry. So this is our short leg. And we know that the short leg times 2 is equal to the hypotenuse. When you multiply that by 2, you just take 2 times 5. You don't multiply inside the square root. So 2 times 5 times the square root of 3 is equal to 10 times the square root of 3. Square root of 3 stays as it was. And then we found all the parts we needed to find. So as long as you keep your relationships straight for the 30, 60, 90, and here they are again. The short leg times the square root of 3 equals the long leg. Put these in your notes. And the short leg times 2 equals the hypotenuse. Okay, those are the two things you need to remember. All right, in this one we are given the hypotenuse. Let's find the short leg first. If you have a choice of finding the hypotenuse, the short leg, or the long leg, find the short leg first if you can. Sometimes you're given that, and that's nice, because everything's based off the short leg. So we're going to say that the short leg times 2 is equal to the hypotenuse, and the hypotenuse is 18 square root of 3. So to solve this, we're going to have to divide both sides by 2. And remember, don't do anything inside the square root when you do that. 18 divided by 2 is 9. 9 square root of 3. It's not 9 times the square root of 1.5. You don't divide both of them by 2, just the number in front. Now that we know what the short leg is, you're just going to multiply that by the square root of 3. See, short leg times the square root of 3 equals the long leg. So you have 9 times the square root of 3 times the square root of 3. 9 times the square root of 3 times the square root of 3. Square root of 3 times the square root of 3 is 3. 9 times 3 is 27. So 27 is the long leg. Okay, another example. In this one, we are given the short leg. I always like it best when they're giving us the short leg, because then you can find both x and y easily. The short leg times the square root of 3 equals the long leg. The short leg times 2 equals the hypotenuse. That one you don't even have to hardly write anything out for. So if they give you the short leg as a whole number, that's like the easiest possible problem you could have. In this one, we're given the hypotenuse. So I have to remember my relationships. Short leg times square root of 3 equals long leg. Short leg times 2 equals hypotenuse. So if they're giving me the hypotenuse, I want to use this formula. The hypotenuse is 24. I know that's equal to the short leg of x times 2. So the short leg is just going to be 12. Once you know the short leg, just take that times the square root of 3 to get the long leg. So they're going to get the same answers I got by writing out the equations. In this one, we're given the long leg. So it doesn't really matter. Let's just remember again. We have the short leg times the square root of 3 equals the long leg. We know that the short leg times 2 equals the hypotenuse. So this time I'm given the long one, so I have to use this equation. So the short leg, which is y in this picture, times the square root of 3 equals 9. So I'm going to divide by the square root of 3, and then I have to rationalize my denominator, which means multiply top and bottom by the square root of 3. 9 square root of 3 divided by 3. 9 divided by 3 is 3. 3 square root of 3 is my short leg. Once you know the short leg, multiply that by 2 to get your hypotenuse. So 3 times 2 is 6 times the square root of 3. Remember, you do not multiply inside the square root when you multiply that by 2. So 3 square root of 3, and then the hypotenuse would be 6 square root of 3. Here's an application problem. It says that we have a pin in the shape of an equilateral triangle, which is going to, equilateral triangle is the 30, 60, 90 triangle. This will be 30 because half of 60 is 30. This will be 60 because in equilateral triangle the base, the angles are each 60. So we have a 30, 60, 90 triangle. Josh will attach the fastener to the back alongside AB. Will the fastener fit if it is 4 centimeters long? The basic question is, okay, this is 6. We want to find this side here and see if it's less than or more than 4. So they're giving us the hypotenuse. So short leg I'll call X, no, I'll call Y because we're calling X the AB. So the short leg times the square root of 3 equals the long leg. The short leg times 2 equals the hypotenuse. I know the hypotenuse, so I have to start with this. So the short leg I'm calling Y equals 6. So what is Y? Divide both sides by 2, you get Y equals 3. That's not what we're looking though. We're looking for AB, which is the long leg in this picture. So we take the short leg of Y times the square root of 3, and we get 3 square root of 3. Now, that's simplest radical form, but that doesn't help me answer the question. I have to get the decimal version of this in order to see if it's greater than or less than 4. So you would use your calculator and figure out that 3 times the square root of 3 is greater than 4. It's 5.2. So that long side of that triangle is greater than 4, so your fastener will fit because the fastener is only 4. All right, so have fun with these. They're really nice to work with, and it's something that's really going to help you out next year when you take Algebra 2. It's the beginning of trigonometry, these problems, and you'll learn more about that later. Thank you very much and have a great day.